Example 2.37. Suppose an object is thrown with initial speed 10 meter per second at an angle pi by 4 with the horizontal. What is the range covered? Suppose the same object is thrown similarly in the moon. Will there be any change in the range? If yes, what is the change? The acceleration due to gravity in moon, g moon is 1 by 6. Okay. Now what is given in your problem is here an object is thrown with the initial speed. So it is thrown with an initial velocity. Okay. So the initial velocity is u is equal to 10 meter per second. And it is projected with an angle theta is equal to pi by 4 with the horizontal. So from the bottom it is thrown with a angle of 45 degree. Okay. Suppose what is asked is what is the range covered. What is the range covered? Okay. So here you take this is how the object is projected. Now it is making an angle 45 degrees with your horizontal. Okay. So the initial velocity at this point is equal to 10 meter per second. Okay. Now what is asked is range. What is the range? Range is the distance between the point of projection and the point where it reaches the ground. So this is your R, range. Okay. So range is equal to, according to the derivation, the range is equal to, you have to use the formula u square sine 2 theta by g. Okay. Now we can find it out the value. R is equal to u square. U square is what? 10 square sine 2 into pi by 4. 2 pi by 4 is what? 40. So it is 2 into pi by 45. 2 pi by 4 is 45. So 2 into pi by 4 is pi by 2 by. What is the g value? G value is 9.8. So we can write it as 100 into sine 90 divided by 9.8. Okay. So it is sine 90 is what? 1. So 100 by 9.8. So if you take this value, if you divide it, and we'll be getting as 10.20 meter. Okay. So this is happening in earth. So this is, we can write it as R earth. What is the second part of the question is, suppose the same object is thrown in the moon. Will there be any change in the range? This was happening in the earth. Now we are going to moon and we are throwing the same object. When we are throwing the same object, what is the range? Okay. But what is given here is, in the given, gravitation of moon is equal to 1 by 6 that of earth. Okay. 1 by 6 that of what? Earth. So R in moon. R in moon is equal to, we are going to use the same formula. U square sine square theta is G in moon we are using. So what is your U square? U square is 10 square. U square is what? 10 square. So it is 10 square into sine 2 theta by 1 by 6 G. Okay. So this can be written as what? This can be written as R in moon is equal to all this term. This is what? R in earth. This is R in what? Earth. So what you can write it? 6 times R in earth. So 6 times what? R in earth. So R in moon is equal to 6 into, what is R in earth? 10.20 meter. That is 61.20 meter. What your question says is there any change? Yes, there is a change. R in earth is 10.20. R in moon is what? 61.20. So how many times it is increasing? 6 times it is increasing. So we can say the range attained on the moon is approximately 6 times that of what? Earth.